When it's summertime.
All right. We were working on our possible zeros of a polynomial yesterday, and I told you I would pick up with a few more like what we did for our last example. So if I want to consider this polynomial, the first thing I would tell you to do is find all the possible zeros. Remember from yesterday, when I'm asking for possible zeros, those are the P's and Q's possible zeros. So we have to list out all of them. Everything can get a plus and minus with it. I know it's annoying, but you really do need to put that plus and minus with each one. Because if you don't, it looks like only positive numbers would divide it. So P, everything that divides, remember P comes from the constant. What's everything that would divide 8 evenly? 1, 2, 4, and 8. And you can have those in any order. I tend to put them in numerical order, but if you want to write them down as you think of them, that's fine. All right, where do we look for the Q value? Yeah, the leading coefficient. So if I'm looking at that, everything that goes into 15. So you can do 1 and 15, 3 and 5. Okay, and then we get our possible zeros. That's P divided by Q. So still plus and minus. So every P over every Q value. So if I start with P value of 1, I have to do 1 over all those things. So 1 over 1, 1 over 3, 1 over 5, 1 over 15. Then I have to do 2 over all of them. So 2 over 1 is 2, 2 over 3, 2 over 5, 2 over 15. Then I have to do 4 divided by everything. So 4 over 1 is 4, 4 over 3, 4 over 5, 4 over 15. Then I do 8 divided by all of those. So 8 over 1, 8 over 3, 8 over 5, 8 over 15. Now, I kind of did this one intentionally to show you how long that list of possible zeros can really get. Most of the time I'm going to give you pretty nice numbers so that the list isn't very long, but I want you to realize it can be long, okay? If you have numbers that have quite a few factors, that list can get pretty lengthy. Now, what do I do once I have everything that might work? And find one that does work. How do we know if it does work? Plug it in equals 0. If it were me, just trying to save myself some time, I try to save fractions for last, just because it's a little bit harder to work with those. So I try my integer values first. Also, looking at this problem, I have something plus something plus something. I'm only subtracting 8 off the end. Do you think we're going to have a positive or a negative 0? Probably a positive one. If all of your signs are adding, you're probably going to have, a negative one. If all of our signs are positive, we probably are going to have to plug in a negative number to get a 0 somewhere. Does that mean a positive 1 won't work? No. But if I'm trying to pick a place to start, I would probably put in my negative numbers first. So I'd probably try -1, -2, -4, -8. Okay. When you put those in, make sure you put the negative in parentheses and the exponent on the outside. So, try them. I'll wait until you guys find one that works. Good strategies. When I type them in, I type everything in deliberately, so I put it in like this. And that way, if it doesn't work, all I have to do is hit second enter, and it comes back up, and I can go change my -4 to another number. This makes it a lot faster if you're trying to check them. Okay, so -4 works. Remember, once we find one that works, we do synthetic division. So my coefficients were 15, 61, 2, and negative 8. Okay, so 15 comes down. Times negative 4 is negative 60, plus 61 is 1. Times negative 4 is negative 4, plus 2 is negative 2. Times negative 4 is 8, plus negative 8 is 0. So that gives me 15x squared plus x minus 2. I want to factor this, so what would we have to do? What multiplies to negative 30 and adds to positive 1? And then what would we do? So, divide those by 3, so 2/5, so 5x plus 2. And 3x minus 1. Alright, my factored form, that's not all of it. It was an x to the third, so I need 3 parentheses. What's my other one? X plus 4. My zeros, if I set each parenthesis equal to 0, I get negative 2/5, positive 1/3, and negative 4. Were all of those on my beginning list? Yeah. Yeah. Okay. Can we do another one? Do this one. What are my p-values?
6, 7, 8.
What are our p-values?
No, everyone.
Oh.
Isn't it? Wait.
P is just everything that divides 2 evenly.
Oh.
So that would be
1 or 2. Plus or minus 1.
Where do we look for Q? First number. What goes into 6 evenly? Okay. How do we get the possible zeros? 5. P over Q. So each P over each Q. So 1 over 1 is 1. 1 over 2. 1 over 3. 1 over 6. And then I do 2 over each of them. So 2 divided by 1 is 2. 2 divided by 2 is 1. Since I already have it on my list, I don't need to write it again. 2 over 3. 2 over 6 is 1/3, and that's already on my list, so I don't have to write it. Okay, now what?
2 over 6 equals 1/3. Okay.
So now what do? Plug them in. Find something that works for me. So once we find one that works, and how do we know it works? You get 0. Okay. Then we do synthetic with that number. So 6 comes down. 6 times 1 is 6. Plus 7 is 13. 13 times 1 is 13. Plus negative 12 is 1. Times 1 is 1.
No.
Negative 2. That gives me 0. Okay. Right here. Can I just factor that nicely? No. So what do you think that means? You put the first two together and the last two together. Sometimes that'll work. Does it work on this one? No. No. What did we do on the last problem when it was an x cubed and we didn't know how to factor it? We did this whole process, right? We found 1 0. This original polynomial is x to the 4th. So how many zeros are there? 4. We found 1. We need to find another one. So you can do a couple different things, but I think the easiest option is to take this, go back to your list of possible zeros, and plug them into this and see if they work. Now, let's be smart about it. If something didn't work the first time, will it work now?
No.
No. 1 worked the first time. It's possible it could work again, or any numbers that you haven't checked yet. Okay, so we just need another 0.
Yes, I see it right there on my list.
What I'm going to do is take this polynomial and I'm dividing it by -2. So I have my 6, 13, 1, and -2.
Where is it?
6 times -2 is -12. Plus 13 is 1. 1 times -2 is -2. Plus 1 is -1. Times -2 is 2. Adds 0. Now we have 6x squared plus x minus 1. Now what can we do?
We have to use the
Okay, what multiplies to -6 and adds positive 1? Okay, divide our 6 back. So that gives us 2x plus 1, 3x minus 1. Okay, my factored form. X to the 4th was the original, so I need 4 parentheses. I have 2. What else would I have? Does it matter what order these are written in? No. Our zeros, you just set each parenthesis equal to 0. So we get -1/2, positive 1/3, -2, and 1, which were all on our list of original zeros. Do you guys know where I'm getting my zeros? I haven't been showing any work. But
Why does it take up half the page? So that's what my last one did. But this one I failed right here.
Alright.
That's it.
I want you guys to do the P's, Q's, and possible zeros. Okay, did you get all those P values? You had 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Q, that's my leading coefficient. This is just a 1 x to the 5th. So what's the only thing that divides 1? 1. So my possible zeros, if I do P over Q, what am I getting? All those P values. That's it. I don't care if you just want to draw an arrow up here when that happens. If your Q is 1, your possible zeros are the P's you already listed. Alright, so now we need one that works. Can you find me one? -3. Synthetic with a -3. I have any hopes of factoring this? So what do we do? Plug in another number. Anything that you've already checked that didn't work still won't work. I'm going to help you out and tell you 1 and -1 aren't going to work here. So try something else. Let's try 2, -2. We could try -3 again. It's possible it works a second time. 2 works. So I'm going to divide by 2 this time. Taking the answer I just got out. Dividing by 2. Alright. Now what? We can do it again. Anything that's already worked might work again. 2 could work again. Or we might need a negative. What do you think? Two works again, so I'm going to divide by 2 again. That gives me x squared plus 0x plus 4, or x squared plus 4. Right, my factored form. X squared plus 4, does that factor? A difference of squares factors. A sum of squares doesn't. You could factor it with imaginary numbers, or if you have something like that that doesn't factor, you can leave it as x squared plus 4. 2 was a 0, so I have an x minus 2, but 2 was a 0 twice, so what do you think I should do? And -3 was a 0, x plus 3. My zeros, it was x to the 5th, so I should get 5 zeros. If you set x squared plus 4 equal to 0, squared equals -4, what happens if you square root? Plus and minus the square root of -4 is 2i. We had imaginary zeros. Now, were those on my list of zeros? No, because it only gives me the rational ones, not the imaginaries or radicals. If x minus 2 is equal to 0, that will give us a 2. But that was squared. That means it happened twice. So we show that with an m for multiplicity. So we say 2 multiplicity 2. It was a 0 twice. And my last one is -3. So that's my 5 zeros. 2i, -2i, 2, 2, and -3. So we got them all. Alright, so this process can be long. If I give you an x cubed, it's not so bad. If I give you x to the 5th, we have to divide a few times and it gets longer. But it's the same thing every time. Are we catching on?
Yeah.
Okay. Let's do, I'm almost done then. Do we need another problem like that right now? No? Okay. I want to, sorry, I'm going to jump around a little bit. Okay. If I just asked you, how many zeros can this function have? Can you tell me? 5. We've been talking about it on every problem, but degree, the highest power is the number of zeros. Now, that doesn't mean there are necessarily 5 real zeros. It could be a combination of real and imaginary, but there are 5 zeros that exist. So your highest power is your number of zeros. All right. If I said, if I asked you to find the zeros, and I gave you something like this. What does it mean to find the zeros? So it doesn't matter. It's already factored for me. It doesn't matter if I have i's in it. We get x by itself, so I have to add my 3 and subtract my I. This one I would add my 3 and add my I. This one I get -5, but what would I have to put with that? Multiplicity of 4. So make sure there's some couple homework questions that's already factored. It just asks you to find the zeros. Don't forget that multiplicity. Doesn't seem like a big deal right now, but next section we'll start graphing these and it changes our graph. So we need to make sure we're including our multiplicities on our answers. All right. Last slide for today. Can we create a polynomial that meets these requirements? So, if -3 is a 0, what has to be in my factored form? If -2 is my 0, what do I have to have? If 5 is my 0. Okay. This other requirement, I can't have any more parentheses, but I could have a number out in front, right? I could have like a 2 or something times this whole thing. So, we just need to find out what that number is. I'm telling you when x is -1, this has to equal 6. So -1 plus 3 is 2. -1 plus 2 is 1. -1 minus 5 is -6. Divide by -12. To meet all the requirements, there would have to be a -1/2 in front of this. Okay, did you understand where I got my parentheses?
Yeah, I know the.
Okay, so the other thing, I told you that this point had to work. If I just plug that in right here, that's saying when x is -1, your y has to equal 6. If I put in -1 right now, it doesn't equal 6, so I have to change it somehow. If I'm not adding any other zeros, that means I can't add any other x's. The only thing I could have is a number multiplied in front of the whole thing. So I just put a there to stand for my number. And then I plug this in. I put 1 in for all my x's and I set it equal to 6. And I solve for what that coefficient would be. Alright.
I get how you get the -1a, but how do you get the 1/2?
Oh, I
never
divided
mind,
it.
you divided. Okay, sorry.
No, it's okay. Alright, I'm going to do some more of those on Monday, but that is our stopping point for today. So you guys have the homework from yesterday. And we ended on problem 30. 37, so today I'm adding 38, 39, and 44 through 40.